Bismillahirrahmanirrahim. My name is Usama Ali Shah and I am going to present my final year project. Our project is an server for telehealth system. My group members are Muhammad Haseeb, Shahinshah and Umar Shah. And our project is supervised by Dr. Tassadaq. Agenda. This is our agenda and these points are explained in further slides. Problem statement. While doing our research, we came to know about these problems which have to be dealt with. The doctor-to-patient ratio was too low as they were not able to communicate, so it has to be raised. As the technology is evolving, so the demand for virtual care also increases because everyone wants to do it on their fingertips. Now, defining telehealth. Telehealth is basically the use of telecommunication technology with medical devices to benefit the doctor and patient at a distance. Now, defining technology which we are using is server. It is a decentralized processing unit which receives raw data, processes it, and after storing it sends the selective data to basic cloud analytic, and it serves as a gateway. Now, importance of telehealth. It is better to know the importance of the technology that we are using. Nowadays, the doctor-to-patient ratio is 1:963, which means that every single doctor has to deal with 963 patients. The global telehealth market value at 440.6 million in 2013, 49.8 billion in 2018, and is projected to reach $266.8 billion by 2026. The number of patients using telehealth services rose to 7 million in 2018, up from less than 350,000 in 2013. Now, the telehealth revenue from 2015 to 2026. This graph explains the telehealth revenue from 2015 to 2026 as x-axis shows the years and y-axis shows the revenue. You can clearly see that rise in revenue as the years passed. In 2018, the revenue was $49.8 billion and is expected to reach $266.8 billion by the year 2026. Now, the literature study. Before proposing our project, we did some research on telehealth. These are the articles and research papers that we studied, published by the following authors over the years.
In this slide, we will be discussing the problems currently we are facing in telehealth systems. No, they are non-intelligent. By non-intelligent, we mean that many of the telehealth systems are unable to be, are not able to take decisions on their own. They're expensive. By expensive, we mean that many of the services, the telehealth systems, or the telehealth providers are providing are quite expensive, and they are insecure. And by insecure, we mean that the systems are insecure. For example, many of the telehealth systems are using simple codes for the treatment of their patients, which are not quite secure and are not able to be that much confidential.
Bismillahirrahmanirrahim. My name is Shahinshah and I am here to present my final. Bismillahirrahmanirrahim. My name is Shahinshah and I am here to present my final year project presentation. In this slide, I am going to present the proposal. In this work, we are proposing development of an intelligent edge server for telehealth system. The edge server can take data from multiple patients through a sensors, process the data locally. If the patient is normal, it gives a real-time prescription, and if the patient is critical, it transfers data to the cloud, and from the cloud it is further transferred to the doctor or physician. The system can be interfaced with wide range of biomedical sensors having USB interface, SPI and 2C. By adding more USB interface sensor, we can handle multiple patients and diagnose the problem without support of physician or doctor. In this slide, I am going to discuss about the working diagram. On the leftmost side, it is the biomedical sensor which are attached to the THD0 and THD1. THD0 means telehealth device 0 and telehealth device 1. Telehealth device takes data from the patient through a sensor and gives data to the edge server. The edge server decides if the patient data is normal, it gives. Our edge server for telehealth include 4 major parts. Number 1, sensor system. Number 2, processing system. Number 3, in this slide, we can add more sensor in our telehealth device, which are USB based interface.
Bismillahirrahmanirrahim. My name is Umar Farooq, and in this slide I am going to discuss about the processing systems which is used in our project. So basically we are using 2 types of processing system in our project. The one is the low power processor, which is of ARM, and the other one is the higher performance processor, which is of the Intel. So the ARM processors take data from multiple sensors and transfer it to the higher performance processor. So on that data, the higher performance processor perform edge computing, which is already discussed in the above slides. It will also perform the local cloud and hosting on their data. Programming application performs in-house process on the data received from the sensors and then transfers the data to the local cloud. For edge programming application, we are using the Python 2.7 and 3.6. We are also using the machine learning techniques, which is also known as the scikit-learn. In the cloud application, a web server interface is provided that gives access to the user using HTTP server. The HTTP server stands for the Hypertext Transfer Protocol, and the HTTP servers sends data all over the web. In this picture, as we can see, the sensors are attached to the data acquisition system, and then it is connected to the Raspberry Pi. After that, the Raspberry Pi sends the data wirelessly to the edge server. The edge server performs different operation on it, and then it sends it to the local cloud. We perform some experiments in order to check and measure the data receiving capacity of a telehealth device. After performing, we have concluded that each sensor transfers the data with a maximum speed of 10 kilobytes to the USB. The USB shows that a single telehealth device can read data from multiple biomedical sensors. While interfacing a telehealth device with multiple sensors, the results confirm that a single telehealth device can access 30 parallel sensors with a maximum data rate of 300 kilobytes per second.
Bismillahirrahmanirrahim. My name is Haseeb and I am here to present our final year project. In this slide, I am going to explain the server application. So basically the server and the client application links the THD with an edge server. And if we talk about the data flow, so a single THD can transfer the data up to 300 kilos sample per second. And if talk about the interfacing of multiple devices, so through the simulation results we have learned that an edge server can be interfaced with 50 THDs with maximum data rate of 15 megabytes per second. These are some typical calculation. For example, if we are using one server, one telehealth device and one sensor, the data rate will be 10 kilobytes per second. If we are using one sensor, one telehealth device and 30 sensors, and a telehealth device has a maximum capacity of using 30 sensors. So if we multiply the 30 sensors with a data rate of 10 kilobytes per second, so we'll be getting 300 kilobytes per second. If we are using, now the other scenario is if we are using one server and 50 telehealth devices. Here I'm going to mention that one sensor has a capacity of using 50 telehealth devices at a time. So, and one telehealth device has the capacity of 30 sensors. So if we multiply 50 and 30, so it will be 1500 sensors for the total. So if we talk about the data rate, so 1500 multiplied by 10 kbps, which is equal to 15 megabyte per second. Through edge services, we will be using different machine learning techniques which will broadcast the sensor data based on artificial intelligent approaches. We will execute the anomaly detection for temperature, heart rate, blood saturation using real-time data stream. It will also perform intrusions detection in the network. The function of the cloud communication application is to operate on the server which gather data of multiple sensors and transfer it to the cloud. Coming towards the conclusion of our presentation, the edge server for telehealth system is scalable to wide range of biomedical application. It is easily programmable and portable to different target technologies. In current evaluation, we have tested the system with wide range of biomedical sensors and also applied different artificial intelligence techniques such as intrusion and anomaly detection. In this slide, I'm going to discuss the CP that we have attained through our project. Now, CP number 1 is permeable, which is targeted by our project. In our project, we are dealing with the problem of distance communication, which was impossible to solve without having the depth knowledge. The CP number 2 is range of conflicting requirements. I will explain this point by explaining it through that we have faced conflicting requirements in the sensor systems and telecommunication interface and in software programming. I will explain it with an example. Like we are using sensor USB-based sensor because it is just plug and play in telecommunications interface. We are using TCP/IPs protocols, and in software language we are using programming. We are using Python language because it is a high level program and easy to understand by humans. In this slide, I'm going to discuss. Continuing the CP's attributes, the CFC number 3, depth of knowledge required. So our research paper is in final stages, and we have performed different experiments on our project and also submitted the result in IEEE conference publication, but they are on hold is due to the COVID-19. Now, targeting the CP number 4, familiarity with the issues in our project. We have faced issues in software programming because the project is targeting a real-time problem, and we were not able to tackle it frequently. for your time. If you have any question, please feel free to ask.